Canada, and we are about to start with our grade 9 lesson for mathematics. I hope that you are ready for today's lesson. And once again, please feel free at any time to ask if you have any question regarding the work that we will be doing today. Right, at the end of the lesson, again, feel free to send me a Twitter if you can. If you feel that there is anything that you did not understand. What we are going to do today, we are just going to zoom directly into algebraic expressions. And later on, we'll also look at similarities of triangles. But for now, we just want to expand and simplify algebraic expressions. Now, consider the following algebraic expressions. I want you to expand these expressions. And the first one, of course, is x plus y into x squared plus xy minus y squared. Now, I want you to break the bracket and then we proceed to expand. And I'm just going to do the first one for you without any waste of time. If you expand an expression, this simply means that you need to multiply out the second bracket by the first two terms in the first bracket. Now, you can see that in the first bracket, we have what we call a binomial. How do we know this is a binomial? Because of the two terms, x and y. So x and y are two terms, therefore the expression is known as a binomial. And if you look at the second one there, or the second bracket rather, you can see that we have about three terms there. The first term is x squared, followed by xy, followed by y squared, which is negative in this case. Now you can see that we have the second term there, and all that we need to do is to multiply the first expression by the second expression. Now the first expression here, as I've already said, it's a binomial. This means you are going to take the first term x and you multiply out the whole bracket. And then you add y and you multiply the y with the entire bracket there. So that is the first step that you do. As you can see, this is reflected here. You have x, open bracket, x squared plus xy minus y squared. Then you close your bracket. Then you go to plus y. Again, you open your bracket. Then you place x squared plus xy minus y squared, and then you close the bracket. Thereafter, what you do, you multiply x by x squared in the first instance here to get x cubed. And then you multiply x by the second term there, which is xy, to get x squared y. And then you multiply x by negative y squared to get negative xy squared. And then you come to y. Again, you multiply y by x squared to get x squared y. Then you multiply y by xy to get xy squared. Then you multiply y by y squared to get y cubed. And you can see that is negative because of the negative sign next to y squared. At this point, you should be ready to collect the like terms. Now, let's group the like terms together. You can see that the like terms here will be x squared y and x squared y there. If you add the two, they will give you 2x squared y. Another pair of like terms, negative x y squared plus y squared. Now the two like terms there will cancel each other. They cancel out because one is negative and the other is positive. At this point, you can see that the remainder of your expression there will be x cubed plus 2x squared y minus y cubed. That will be your expression once you have multiplied the binomial by the trinomial. So you can see even our expression, the last answer there is a trinomial. It is a trinomial. Now we need to proceed to the next one, which is x minus 1 into x plus xy plus y. And I want you to do this expression. If you have a paper and a pen with you, please take it out, because now we are going to work out and expand the algebraic expression. Can you expand x minus y into x plus xy plus y using the same method that I've taught you in the first example there? Can we carry on with the second one? If you have done so already, please feel free to indicate at any time and tell me how did you do it. Can we go to Denzel? Denzel, can you tell us how did you find the second expression? X minus y into x plus xy plus y. As we welcome Onkabetse. Right, in the absence of a hand, I will carry on. Let me carry on. So the manner in which you will do, all right, so Denzel is still working it out. Thank you, Denzel. I just saw your chat. Is there anyone perhaps who would like to attempt before we can carry on? I'm giving you an opportunity to work it out and then tell me what the answer is. Right, let's go to Bongi. Bongi? Right, in the absence of a hand, I will just help you out. This is the first one that we have done. And of course, the second one, once again, this is a binomial, which is multiplied by a trinomial. And what is important, as I've already indicated, is that you will take the binomial here, the first term, and then you multiply it out with the second bracket there. And then you take the second term, which is -1 again, and you multiply that with the entire bracket. So the first one, you'll have x into x plus xy plus y, because we are multiplying out the first term with the entire term here in the bracket, the entire trinomial. So you take the first term of the binomial, you multiply the trinomial with that term. Then you come to the second term of the binomial, which is -1, and then you multiply it out with the trinomial. Now, x times x gives you x squared. X times xy gives you x squared y. X times y gives you xy. And then you come to the second term of the binomial. You multiply -1 by the whole expression there, the trinomial. So everything here will be multiplied by -1, meaning that -1 times x will give you -x. -1 times xy will give you -xy. -1 times y will give you -y. Now at this point, you can now collect the like terms. Can you see that we have the like terms here, xy and xy? Those are the like terms. And those are that is the only pair of like terms. So you can see one of the xy's there is positive and the other is negative. It should then be very clear at this point that the -1 and the +1, I'm talking about xy here. Xy minus xy will be 0. So they will cancel out and you'll be left with x squared plus x squared y minus x minus y. And at this point, this will be your factorized expression. So that is the next one. And of course, if you go to the third one, you do the same as well. You can see that you are multiplying the binomial by a trinomial. We call this a plus b a binomial because of the two terms. And we call the next a plus b plus c, we call that a trinomial because of the three terms. Tri means 3. Pi means 2. Now, you take the first term and then you multiply it out with the expression, the trinomial. Again, you take the second term, which is b, and you multiply it out with the trinomial again. And of course, we should know that if you multiply a by a, you get a squared. Then a times b, you get ab, whereas a times c gives you ac. And then you go to b, b times a gives you ab, b times b will give you b squared, b times c will give you bc. Now at this point, you should be able to add them together. You'll have a squared. You can see that ab and ab are like terms. And you group the like terms together. If you add ab and ab, you will get 2ab. And of course, the entire expression there will be a squared plus 2ab plus ac plus b squared plus bc. And that's how you multiply the two. The next one is here. Once again, you multiply x by x squared minus 9. X times x squared gives you x cubed. And then x times 9 will give you minus 9x. Right, before we can go to Nosipo Pungula, Maybe Nosipo would like to help us with the next one here, which is number 4. Let's go to the 4th one, Nosipo. In fact, the 5th one, sorry. Before we can carry on, let's go to the 5th one.
We don't understand. We don't. Everyone is
Anna?
complaining in the chat box.
All right, I can't hear you properly.
Sir, can I please tell you where I don't understand?
Okay.
Will you please go back to number 3?
All right.
So the first row, the second row, I don't understand how did you distribute it. But at the third row, I understand.
Okay. Right. Let me re-explain. If you can look at the first expression there, A plus B into A plus B plus C. What I want you to do, what this simply means is that you are multiplying A plus B by A plus B plus C. So those brackets means multiplication. Now, it is important to know that we need to separate A and B, meaning that you first take the A and you multiply it up with the bracket there. And thereafter you take B and you multiply it out with the bracket. That is what we have done in the step 2. Here, this A here, it's here now. Can you see it?
Yes, sir.
So you put this A here, and this A plus B plus C, it is this expression. And then you
Yes,
put
sir.
it there. And then plus B. Here is the plus B. Open bracket, the same expression. So you simply multiply the second expression by the 2 terms.
Oh, sir, now I understand. Thank you,
Yes.
sir.
Okay.
But sir, please don't move the slide.
All right. I'll just explain that thereafter you collect the like terms, and then the like terms are A, B, and AB. And once you have added them together, they will give you 2AB.
Thank you,
That
sir.
is what you have in as far as this expression is concerned. Can we move from the slide now? Is everybody comfortable? All right, Unkabezi?
Yes, sir. You can move.
All right, sure. Right, we are just going to move to the last one, which is A into A minus B. This should be very simple. A into A minus B. Right, let's go to Tino.
Good morning, sir.
Morning, Tino.
I'm not really sure, sir, if my answer will be right, sir. But I think that like you add A. Okay, you don't add A, say you like put A squared and AB. Your answer, sir.
Okay, so what will be your answer?
Will be A squared and AB, sir.
So it will be A squared minus AB.
A.
So definitely
Yes,
that's
sir.
correct, Tino. You are right, because when you multiply A by A, you get A squared.
Yes, sir.
And when you multiply A by B, you get AB. So basically, you will have A squared minus AB.
Yes, sir.
That is what you will have. Now, we have done this, and then of course, we are coming to factorization now. We are now going to factorize. Remember, this is a word example where you need to factorize And we have done factorization before, where you take out the common factor, like in this case, a minus 2. The 2 minus a, you can just multiply everything by negative, and then it will affect this negative, which will be plus. So you'll have 5 into a minus 2 plus b into a minus 2, as we have there. And a minus 2 becomes the common factor there. And then once you take it out, you'll be left with 5 plus b. We have done this before. We have to revise this work now on factorization. Can you factorize this expression? I just want to test your knowledge of factorization. Can you be able to factorize this on your own if you get something like this and we say to you factorize? Nkabetse?
No, sir, I forgot to put my hand down.
Okay. Can we get someone to tell us how do we factorize the expression 12x plus 3y? How do we factorize this expression? Yes, Bugs? Bugs, please go ahead.
No, it was a mistake.
All right, Manga, let's go to Manga then.
So I think the real reason why we're all confused is because of last week, sir. When you were
Come again?
teaching us. The real reason why we're all mostly confused, or why I'm confused, is because of last week, sir.
What about last week?
So we were very confused last week, sir. So
Or
yeah.
about factorization? Okay. All that I need you to do now is just to take the common factor. So there are 2 terms here, 12x and 3y. Now, is there any common factor? Let's start with the numerical values now before we go to the variables. So between 12 and 3, is there a common factor there?
Yes, sir. It's 3.
Is there a number that can go to 12 without a remainder?
That's
and also
3.
into 3. What is that number? What is that number?
3.
That number is 3. All right. So this number is 3. And of course, once you take it out, you'll be able to see that you will be left with 4x plus y in the bracket. So 3 is the common factor. Therefore, you take out the common factor, and then this will be 3 into 4x plus y. Can you factorize 18ab minus 3bc? Is there a common factor?
Yes, sir. It's 3. And B.
So you say the common factor will be?
3 and B.
Okay, so you can simply put it as 3b. All right.
Yes,
So
sir.
now, well, you can see on the numbers, 3 is the common factor, and the variables b is the common factor. Therefore, 3b into what remains is 6a in the first term, and then c in the second term. And to test whether your factorization is correct or not, you can check by multiplying out the whole bracket here. So in other words, you'll multiply 3 by 6 to get 18. Then b times a is ab. So can you see that in the first term, that is correct. And then in the second term, once more, you'll multiply 3. The number that is there next to c here, the coefficient of c is 1. So you multiply 3 by 1 to get 3. And if you multiply B by C, you will get BC. So 3BC there for the second term. Can we apply our minds in this one here?
So can you please give me time to try it?
Okay. Everyone is given some chance to work out this problem here as we revise factorization. I hope that you have a pen and a paper. Right. I hope that we have done that by now. Back send is up. Please go ahead, Bugs. Bugs, I can't hear you. I cannot hear you, Bugs. Right, let's go to Tino. Tino, please go ahead.
Oh, goodness. So may I please attempt?
Okay.
I think the answer is negative 2a in bracket b minus 4a.
All right, for the first one.
Yes, sir.
So you're saying the answer will be negative
2a in brackets b plus 4a, minus 4a.
All right. Remember, to work smarter, what you can do, you can start with the negative 2. You take out the negative 2. Obviously, you'll be left with AB there. And then here, you'll be left with 4. Ne?
Yes, sir.
And then you come and take A. So you'll be left with B here. There won't be any A anymore, because there's only one A there. A is also a common factor. Can you see that?
Yes, sir.
So A is also a common factor, which means you need to take it out. And then, of course, once you have taken out the A, you should be able to realize that the remainder will be B plus 4. And in the second one, 4AB minus 8ABC.
So I'm not sure if it's correct, but I got 4ab in bracket 4c. Yeah, 2c.
Okay, 2B. All right, in this case, you can see that 4 is a common factor. A is also a common factor. B is a common factor. So you'll take 4AB as the common factor. And what remains there will be 1 in the first category there, minus, in this case, it will be 2 and the C there. So you'll have 1 minus 2C. 4AB, open bracket, 1 minus 2C. And that brings us to the end of the revision for factors where we...
So why do you write the 1 at the last?
Come again?
Question.
The last one?
Because the previous expressions, we haven't been writing the 1, but yet at the last one, we're writing 1.
Do you know why? That's because you are opening a bracket. 4AB, open bracket. And when you open bracket, you have the remainder of 1 there, because if you multiply 4AB by 1, you will get 4AB. Remember, what is important is, at the end of the day, once you have an answer, you should be able to test, to check whether your answer is correct, so that you can, and if your answer is correct, once you multiply everything out, the product will give you this original expression. But if you get a different expression altogether, then it means something wrong happened.
Thank you, sir.
Yes. Now I'm coming to similarity of triangles. And I know that you have done similarity some time back, but I want us to list the conditions for similarity of triangles. How can we say the two triangles are similar? What are the conditions for similarity in any triangles? Remember, before you answer the question, remember there's a difference between congruency and similarity. There are congruent triangles, there are also similar triangles. So now I'm talking about similarity. What are the conditions? Tino?
All pairs of corresponding angles are equal.
All pairs of corresponding angles are equal. And what about the sides? Are the sides also equal?
No, sir.
The sides are not equal. All right. But the sides should be in proportion. The sides should be in proportion. So we are given two triangles there. Triangle ABC, at this angle here, C, the point there is C, then EDF. I want you to look at the two triangles thoroughly. It should be clear at this point that the two triangles are not congruent, meaning that they don't have the same size. All right, the shape might be the same, but they don't have the same size. They have different sizes. Now the key question is, are the two triangles similar or not? Give reasons for your answer.
They are similar, sir.
Why do you say they are similar?
Because
Because
Sir, can you please repeat your question?
are the two triangles similar? And if you say yes, why? Why do you say they are similar? Do the two triangles have to make
because all the angles are equal.
the angles are equal?
Yes.
Can you mention the equal angles?
B and E, A and D.
Okay. F and C as well. Yes, the two triangles are similar because they've got the corresponding angles are equal. If you look at angle A, that is equal to angle D. If you look at angle B, which is hashtag there, it's equal to angle E. If you look at angle C in the first triangle, that is equal to angle F. So yes, the two triangles are similar. Now, the correct notation is very important when you name the similarity between triangles. For example, the notation for the triangles above should be triangle ABC is similar to triangle DEF because it indicates that angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F, as we have just said. Now, once you prove similarity, then you should be able to know that AB over DE will be equal to BC over EF, which is AC over DF. The sides are in proportion. AB over DE, you can see AB over DE, BC over EF, AC over DF. The sides are in proportion. The two sides are in proportion, or rather the three sides, sorry. Now consider this triangle. triangle ABC. Now there's a line that is cutting the triangle, the line PQ, and that line parallel to AB.
Hello.
Now prove that triangle ABC is similar to triangle PQC.
Wait, renegade.
And thereafter, calculate the length of AB if AC is 10 units, PC is 4 units, PQ is 2 units. Just to show you the triangle ABC and the line PQ, which is parallel to AB. So if you have drawn this triangle, perfect. Now I want you to prove that triangle ABC is similar to triangle PQC. You can see C is a common angle there. C is a common angle. So you already have one of the requirements, one of the conditions. Angle C is equal to angle C because it exists in both triangles. And then you need to calculate the length of AB if AC is 10 units. Right, let's go to Deidre. Let's go to Deidre. Are you there, Deidre? Right, we can just carry on.
Sorry, sir.
Yes.
Please repeat the question, sir. I don't really understand what we're supposed to do, sir.
All right.
I'm supposed to prove that it's similar or not, sir.
Triangle ABC and triangle PQC. So can you see the two triangles? The bigger triangle ABC, smaller triangle PQC.
Yes, sir.
What is important if you want to work smart, you can actually take out triangle PQC and put it on the side. It will be easy for you to see or to work out the similarities of the two triangles.
So where do you get the units?
There are no units at this point, but the units come only later. In the first instance, you prove similarity without units. Let me give you a hint. You need to use your knowledge of parallel lines. Remember, when the two lines are parallel, angles are formed. In this case, excuse me, I'm sure they said, yes, when the two lines are parallel, there are angles formed. If you look at angle A, that angle is equal to angle CPQ. The two angles are equal, and we call them corresponding angles. Angle B is equal to angle PQC. Those two angles are also equal because the two lines are parallel. PQ is parallel to AB, and the last angle will be C. Can you see that in these two triangles, C appears in both triangles. So angle C is equal to angle C. Therefore, triangle ABC is similar to triangle PQC.
So isn't angle B 90 degrees?
No, it's not 90 degrees. It looks like 90 degrees the way it's drawn.
Oh,
Yes, it looks
it
like 90
was.
degrees, but we are not sure because we don't have any measurements. We have not measured the angle. So what we know is that angle B will be equal to angle PQC because the two lines PQ and AB are parallel lines. Therefore, this means that at this point, you should be able to conclude that in triangle ABC and PQC, angle C appears twice. It appears in both triangles. Angle ABC is equal to angle PQC. As I said, those are corresponding angles. Angle BAP is equal to angle QPC. Again, those are corresponding angles because of the two parallel lines. And we can conclude that therefore triangle ABC is similar to triangle PQC. Reason, angle, angle, angle. We have proved that the three corresponding angles are equal. Now that you have proved similarity, it should be easy to calculate the length of AB. Remember, I said the sides will be in proportion. Now, if the sides are in proportion, then it means AB over PQ
I
will
don't
be equal
understand.
to BC over QC, which is in turn AC over PC. Please make sure that you study the sides which are in proportion when it comes to similarity. And if you face any problem, you will tell me. So once you have used this sides in proportion, you will see that AB over P, the length of PQ now is given as 2, and then AC is given as 10, and then PC as 4. And then you just substitute, and AB will be 5 units. Because for AB, you multiply the AB by 4, even this side by 4, you'll be left with 2, and then you multiply by 2 both sides, then you will have 5 units there. Now, at this point, I just want you to use this as your homework just to use the properties of similar triangles to find unknown sides. And then you need to calculate the length of PS if triangle ABC is similar to triangle PTS. Again, I want you to check the two. Check these two triangles and tell me whether the two triangles are similar or not. So in this case, you are given the two angles here, even this side, two angles, two sides. Then you have an unknown side, which is X. And then I want you to find the value of X. Once you have proved that the two triangles are similar, then you need to calculate the value of X, and you are going to use the sides which are in proportion. So please revisit the similar triangles. We have done that, in this term. Make use of the lessons that we have drawn there on similarity to find the side, if the sides are in proportion. I can already tell you that the sides look, they're in proportion here. You have 12, you have 3, you have 2, you have 2, there's 76 is there, 45 is also there. So you can see that the two triangles are actually similar.
And so the missing angle is 59 degrees.
Yeah, then you can find X. But this actually brings us to the end of our revision exercise this morning. And this will be your answer to the second question there, where you have to find the value of X. You
Okay,
can see
so
that Yeah, you can see that AB is in proportion to PT. And AB is 6, PT is 2. Therefore, you can find the value of X, which is going to be 4. I hope that we will carry on doing some revision in the next course of, in the next day until we meet again tomorrow. So this is just the homework that you can do just to prove similarity. And then you can calculate the length of PM and PQ. Please take this homework and then we can look at it tomorrow. If you have taken the homework, I want to also say that it was nice once again to do revision with you today. Let us carry on. If you still have a problem, WhatsApp me on 082 623 2148. And of course, we are found on our social media pages at Africa Teen Geeks. That is our Twitter account. And we are also on Facebook. Just search for Africa Teen Geeks. And this lesson was brought to you by the Lockdown eSchool in partnership with the Sasol Foundation. And thank you once again for taking the time and the trouble to participate in this lesson. Until we meet again tomorrow. Thank you very much.
Bye, sir.
Thank you, sir. Bye, sir.
Bye, sir.
Bye, sir.
Bye, everyone.
Renegade.